Hello, everybody, and welcome to our presentation today about high productivity with manufacturing with NXCAM. Just a little heads up here, because of what we're covering and the speed that we're trying to cover within a half an hour, John had to pre-record his presentations, but rest assured, we have John live with us today. John?
Hi, everybody. I'm glad you made it here today to join us for this session. And as questions arise during the webinar today, feel free to put them in our chat, and I will address them as time allows.
Great. Thank you, John. So our agenda today is, we're going to cover CAM as your manufacturing platform. For those who already have an XCAM, some of it may be not new information, or my hope is even when John runs through some of the newer solutions on CAM, you're going to, on the platform itself, you're going to see, hey, that looks different. How can I leverage that? But we're going to cover three areas, deeply today. Probing, turning, and feature-based machining. So my name is Dan Wibbemeyer, for those who I haven't met, but I have a few slides to cover here with you, and then we will get to John's presentations, and then we will have a very short wrap up in the survey. So if you could stay on for that, I'd greatly appreciate it. So who are we? Swoosh Technologies. We have been working with Siemens since 2005. We are certified not only on the NX products that Siemens has to offer, but also on the Team Center for Data Management. One of our areas that we are strongly focused on is manufacturing. So John actually has a team that works not only on the NX side, manufacturing side, but we are getting deeply involved with shop floor communication, shop floor verification, machine simulation. So that's where we're being pressed really hard by our clients today, is how can we do more on the shop floor? So Siemens, as a manufacturer in the CAM business, 50 years. So they have a pretty big footprint worldwide. What does people like SimData, a recognized consultants, say about SimData, or say about NX? One of the strongest product offerings in industry today. So with 13% of the market share, in a very segmented market, that's a really big footprint. So areas where we excel at, when I say excel, I mean we are one of the leaders for not only ease of use, but for speed, time of programming, and getting accurate information, the correct information the first time for the shop floor. So that's things that we will try to highlight a little bit today, but once again, everyone is trying to do more with less people, and sometimes the people don't have the same knowledge as other people. So how can I capture that? We're going to show you a little bit of that today on the feature-based. So we are an integrated solution. We're not going to show you all these today, but it's not just fixed axis machining we have. We have a comprehensive solution from the post-processing, the simulation, on the shop floor. What information do the users and the operators see, and how can they communicate? So these are really areas that are critical for manufacturing today, the communication aspect of it. Areas where we excel using some of our capabilities with NXCAM, anything with kind of complex cutting, our complex machines. This is where we actually coexist with a lot of other solutions where, hey, the other solutions can get it done, but it's a struggle, so they bring in NXCAM. Program automation. You're going to see this today. A lot of people talk about feature-based machining, but Siemens has taken it to a new level to where it can capture best practices, where you can build in that knowledge of people who have been there for a while. How do you do things at your shop? So this is where Siemens can get crazy numbers, like 90% improvement on programming time based on their feature-based applications. program automation further with PMI. So for those who do any kind of engine build or in the supply chain with any kind of aerospace, you have seen PMI. It is only going to get more prevalent as the days go by. How do you leverage that in your process and your workflow? How can you capture that once again to program more accurately and more efficiently? Process and simulation. We wouldn't be a comprehensive solution if we did not have a complete solution for communicating with the machine tool on the shop floor. So not only does Siemens simulate, we can also emulate. So we emulate with the NX, and we can actually simulate with the machine controller itself, so you can do 100% virtual commissioning. What you see is what you get before you cut. You're going to know for certainty. And finally, we wouldn't be a comprehensive solution if we didn't have good tool-based managing system on board. So once again, please stay on when we're done with John's presentations, and we're going to have a short discussion, then close. But this is the agenda, and I'm going to turn it over to John now. Thank you.
Hello, everyone. This is John Vincent from Swoosh Technologies. And I'm here today to talk to you a little bit about NX CAM and how flexible this system is to complete your work on a daily basis, regardless of what types of machines or what industry that you are part of. So over the next 20 minutes or so, I'm going to go ahead and just give an overview of NX CAM and the interface and how things will work across multiple environments. In this case, I'm going to be utilizing a mill turn machine to demonstrate how all these operations can be programmed right inside of one part file. So first things, taking a look at NX CAM, I have a part file open and a part programmed already. I just kind of want to show you the results right now. So here we are looking at our operation navigator. This is where we really live when we're a CAM programmer and we spend most of our time. Inside of our operation navigator, or you may hear it referred to as the ONT, we have some different views, and we use these different views to complete different types of work. Currently, I'm in the program order view. If I go ahead and expand all of my operations, we can see that I have a variety of operations organized by operation type. There's certainly no requirement to do this. It's just for this example that I grouped all of my probing operations, turning operations, and then milling operations. The important thing to realize is this is just the order of operations as things will run on the real machine tool. As we progress to the next tab, this is going to be our machine tool view. And I currently have a machine tool loaded in my NX environment, and we can see that the machine tool is visible in my graphic window, as well as what you can't see right now is the configurations are pointing specifically to this post processor. So I have no chance of errors of posting out code using the wrong post or to the wrong machine. Additionally here, we can see that we have our milling spindle and machine pocket, which is where we place all of the tooling that we want to use in our particular program that we're working on. Moving on to our geometry view, here we can see the geometry structure within NX. Again, this is really kind of mimicking how the machine works. At the top level of the tree, we're specifying our machine 0 point. So what corresponds to the machine 0, again, on the physical machine tool. And from there we have our different coordinate systems and work geometry specified for both milling and turning operations. And you might notice that we have some other groups, such as these feature groups, where we're able to group like geometries in the case of different drilled holes, feature holes that we can use the same geometry to reuse for things like drilling, tapping, reaming, chamfering, so on and so forth. And lastly, we have our method views. This is a great way to minimize the number of settings you have to make inside of each operation perhaps to inherit things like our stock values. Oftentimes we have some institutional knowledge of how we like to manufacture our parts. Maybe you leave 50 thousandths for our after roughing operations and 20 thousandths after a semi-finish operation, and of course down to 0 for our to achieve our nominal dimensions of the model. All that information can be embedded here inside of your method groups, and as you attach geometry, or I should say operations to the method groups, that information is going to be inherited into the operation, so you're not having to make these settings in a repeated manner. All right, so in this example, before we dive into the different types of operations and a little bit more details, I want to go ahead and just take a look now that you're familiar with the different Operation Navigator views. So here I have a variety of different types of operations that we've used on this part. Starting at the very top, we'll see that we have some probing operations. And in this case, it's nice to see that inside of NX, we can go ahead and probe our parts, in this case, to set our work offsets. I could go ahead and display my IPW at any point in time and use the toolpath animation to view what our operation is going to be doing. In this case, I'm doing a 4-point probing operation of this boss feature. This is really going to be setting my X and Y location on my machine tool for this specific part, as well as the next operation would simply be probing a Z position, again, to set the operation, or to set the location. So these values are going to set, in this case, our G54. So that's, again, going to correspond to the location I've set my G54 coordinate system in my geometry view. Instead of turning, we support many different operation types. One of the newest operation types is prime turning. This is an example of a new tooling type and strategy used for turning to really increase feed rates, increase material removal rates, with the same types of machine tools that you already have. So NX can support the variety of prime turning inserts that we have, both style A and B, across a variety of different operations in turning, from facing, turning, boring, so on and so forth. We also are able to support point-to-point output and cycle output. And what that means, if we look at a prime turning output, this operation is set to generate our code in a point-to-point manner. So we'll see each and every line of code, kind of a conventional way of programming. Some organizations like to be able to use programming cycles or CAN cycles. A good example here in this OD operation, we can see that I am using a machining cycle output type. And what that does for me when I post out my code is we'll see, instead of having every line of code, essentially what we end up with is a part profile being defined and a cycle calling this procedure. And essentially then the machine control, based on some parameters of our depth of cut, stock allowances, actually determines how to cut our part. But the important thing is we can support any method you want to see there. Coming down to some of our milling operations, we have both planar milling operations, 3D milling operation, multi-axis operations, and we can see in these operations, we can see right in our graphic window that we can replay our toolpath with toolpath animation. And we also have the ability in an operation such as this floor facing, where we have multiple cut levels, that we can choose to see the toolpath by level. So as I'm playing through my toolpath, I'm only seeing the particular level that I'm cutting right now. And as I move to the next depth of cut, my graphic will update right along with my toolpath. We have a lot of flexibility in how we show our toolpaths. We can do things like showing arrowheads, so we can quickly view the orientation or the magnitude at which our tool is going to be driving. We can also show things like our tool trace, tool axis trace, to get an idea in multi-axis operations. Where is the tool going? We can also look at a number of other ways that maybe we want to get a good understanding as we select multiple operations. How do we want to view our toolpaths? Maybe I'll choose by operation. And you can see each operation, the color of the toolpath has now changed to signify graphically that we're looking at various operations. So a lot of flexibility in the system to see things in the manner that makes the most sense to you. And lastly, we have some drilling and hole making type operations that have been created with feature-based machining. We'll take a look at some of these details a little bit later on. So we're going to do a little bit more granular look at some of these different operation types, kind of the look and feel from an operator, CNC programmer perspective. But in the end of the day, we're going to go ahead and run a simulation to verify that everything we've programmed is going to produce the part we want and be safe out at the machine tool. And in the end, we'll achieve some first time right production on our machine tools. So as we run some simulation, we can see that we are going to be able to simulate all of our probing operations, turning operations, milling, and drilling operations. And we can do that all inside of one environment. And that's really important, that we're not having to switch between different software packages or even different modules. We're doing everything all in one environment. It's really a benefit to the programmer. One, to reduce the chance of errors, and two, just for time savings, not having to manage data and information across multiple platforms. In NX, we're very intelligent in terms of identifying what type of an operation we're using. Our post-processor doesn't have to have any manual intervention to specify that we want to get turning output or milling output or 5-axis output versus positional output. Our post-processors look at the operation type and the tooling types and method types and obtain all this information automatically. And that ends up leaving very few decisions or repetitive actions for the programmers on a day-to-day basis. And again, this just increases our throughput. And as we finished up our turning, we'll come and look at our milling operations. In this case, you'll see that we're even using a right-angled head. So we can support any number of combinations of head attachments, facing heads, multi-axis heads, to be defined and used and programmed inside of NX CAM. So whatever your situation is with your type of machine tools and accessories you have, all can be supported inside of NX CAM. And here we'll see that we have some multi-axis operations now. And the great thing about NX is when we use a multi-axis operation, everything's automatically defined. That based upon our machine tool definition, limits, we're always going to be machining the accessible regions of our part, again, without any manual intervention to obtain these results. We can also stop at any point in time and do an analysis on our IPW. NX always keeps up to date with the actual current stock condition, our in-process workpiece. As I zoom in on my part, I can use this heat map to really understand how much material has been removed or remains on our part file. So as I check any given surface, I can see how much material is remaining, perhaps how much material is left inside of corner radiuses. Maybe our tool that we used was larger than the actual desired feature. Great way to catch this type of information and see that we have more work to do on our part, and certainly not allow it to get out to the shop floor before it's done inside of our program. Once you've completed your machine simulation, it's time to go ahead and post out that code and send it out to the shop. So we'll come down to our post-process dialog, and we'll see with our machine tool set up in our environment, we're limited to post to the appropriate machine that this job was programmed for. So once we go ahead and run the post processor, this code is going to be ready to go out to the shop floor, and we know that it's going to be error-free and produce a good part the first time through. All right, with our post run complete, we can go through, take a quick look at any of our code, make sure it all looks good, and we can go ahead and send this out to the shop floor now. So next we're going to take a little bit of a deeper dive into some of these topics for probing, turning, and milling operations. Next up is going to be probing.
Okay, please hold 1 second. We're pulling up the next video. Of course, this worked perfect when we were testing it. So what John just showed too was kind of a lot of it put together, and we were gonna. Oh, it looks like Alex.
All right,
got
we're
it
going to go ahead and
here.
take a look at on-machine probing in a little bit more depth here. So starting with NX 2306, which is the version I'm working in here today, we have some new operations for on-machine probing. So to go ahead and kick this off, under the probing type, our new option is called on-machine probing. We always had mill part probing and turn part probing. On-machine probing is a whole new approach to how we are handling on-machine probing, and I'm going to show you a little bit about the functionality. So in this case, I'm going to go ahead and select my probe. I have a 6mm probe in my machine, my geometry group, method group, and go ahead and say OK. Now, this on-machine probing dialog is really agnostic to what type of machine control you have, whether it's Siemens, Heidenhain, or getting into Fanuc, Okuma, things like that. Currently, Siemens and Heidenhain is supported, their cycle types. And we'll see that as I pick geometry under my specified probing geometry, as I start picking some geometry, I have different cycle types that are available to me. In my case, I have a Siemens controlled machine loaded. I'm only going to see the Siemens cycles here. So the benefit to this, as opposed to some past practices where you needed to know as a programmer the specific cycles that you want to run, or that I need to know what a bore cycle is versus a boss cycle versus a single point. I don't need to know that any longer because that information is going to be presented to me based upon my geometry selections. So right now, I'm going to go ahead and make a couple quick settings here. I just want to set a clearance plane. And I'll pick my cycle 977 for my spigot. And in this operation, we can change or set all the parameters for a probing cycle that is going to be a one-to-one match of what's on the actual machine control. So in this case, if I want to specify the height of my probing, I can simply just pick on my part geometry, and the cycle is going to update. Now we can see here that our clearance plane is incorrect for what we need. So let's go ahead and make some changes to our clearance plane cycle. And you can easily see as we're changing the settings, our toolpath is updating right away. If we continue with our different settings, we can go ahead and influence the toolpath even more. So everything you can do on the machine tool with the cycles, you could do here inside of NX. Even in this instance, just changing the clock position of where we're starting. And that's it. I mean, that's as easy as it is to program some of these operations. So let's go ahead and generate that, make sure everything's good to go. We can go ahead and verify right inside of this operation. What the toolpath looks like. And we can see that we are driving the actual toolpath that's going to happen. The old probing operations, you couldn't do this. Essentially, you saw where the probe was going to go, the events triggered in the post, but we didn't see specifically the actions that were taking place inside of the GUI here. We also support post layers and CSE support, so the common simulation engine for simulation. Again, let me go ahead and activate my machine tool, and we'll be able to see that right away I'm able to go ahead and post-process my machine cycle code for the machine. And we'll have full support of this for simulation as well. So here we'll see the result of our probing cycle on this Cinemeric controller, as well as if we were going to do some simulation and we would actually be driving the machine cycles just like the real machine would do. Pretty great to be able to do this all right inside of your CAM system. All right, up next, we'll talk a little bit more about turning. All right, now that we have our 4 coordinate set with our probing operations, we can go ahead and look at our initial turning operations that we want to complete. So generally in NX, we're always working with 3D models, but in the case of turning, we really want to work with a 2D cross-section. If I look at my geometry view here, I have what's called a turning workpiece. And turning workpiece looks at the parent objects, in this case my 3D model of my part and 3D model of my blank geometry, and creates revolved cross-sections of that geometry. If I go ahead and suppress my blank and part, we can see that resultant geometry in the graphic window now. This will allow me to go ahead and create my turning operations. In this case, I'll start with a rough turn prime operation. And I'll go ahead and specify my geometry groups and method groups appropriately. So instead of turning, things work slightly different than milling operations, where we're selecting faces or regions of cut area and wall geometry. Inside of turning, we're working with containment. Essentially, we're identifying regions of the part that we want to manufacture. So in this case, I'm going to start with a axial trim plane, picking some geometry on our part, and we can see right away I'm getting some tool paths that are going to be generated automatically with my selections. We can change things like cut direction. How do we really want to have this part be cut? Maybe I want to change some non-cutting engages, retracts, things like that. I think we'll give it some extensions here. So, quite easy to create some turning geometry. And when we play through and look at this, we can view our toolpath by just looking at the insert, looking at 3D model. In this case, in prime turning, we're really cutting the wrong direction right now. We want to be cutting, leading with kind of what is traditionally thought of as the backside of the insert. So right inside of our operation, we go and just flip that tool around the holder. On a mill turn machine, that's really easy for us to go ahead and do. And so as we want to go ahead and play this through, we can take a look and see that we're actually colliding. We're getting IPW collision information while we're not even inside a simulation. We're checking against our IPW right here in our regular programming environment. So that's great enhancement that we're able to really review that IPW information. We can always go through in our operation and reuse this information. So I just did a rough face of this part. Let's go ahead and just regenerate that real quick. And I can just go ahead and copy and paste this operation. And utilizing the same tool, I can now do some turning of this part. And what that might require for this particular machine is for me to reorient the tool holder. I no longer want the tool to be vertical, I want it to be more of a horizontal orientation. Come and just reorient this tool. And now we can take a peek and see what our containments look like. I'm going to make a couple changes. I really want to change some of the regions that I'm going to be trying to cut here, some of the different aspects of it. And so now we can see that with our current containment, we can access some specific areas of our part. And this is always intelligent that if we're changing our settings, here now I unchecked flip tool around holder, change the orientation of the tool, I can see more geometry here. So maybe I don't want to cut all of this in one pass, so let's go ahead and apply some more containment to this part, and we can see how quickly our tool paths are quickly created here inside of the turning environment. So there you can see how quickly it can be to create your turning operations. Next up, we're going to look at a little bit of more information about drilling. And the last topic we're going to talk about here today is, we're talking about drilling, but really what we're going to do is use some feature-based machining. So feature-based machining is an approach that allows you to find features, group features, and manufacture features, all based on a set of rules. So there's a number of out-of-the-box rules that come with NX. However, you can also create your own rules if you'd like to go through and embed your company's practices or policies inside of your software. So let's just take a look at a little bit of what goes into feature-based machining. So the first step is really finding some features. So up here on my ribbon bar, I'm going to go ahead and click on Find Features. And we can see under parametric features, there's a good number of different types of geometry, and we can drill down into each of these to find different types of geometry. These are all the out-of-the-box feature types that can be found. For the sake of this demonstration, I want to focus just on our step features. Step features are really hole features. One-step hole, two-step hole, three-step holes. Those correspond to like through holes is a one-step hole. Counterbore hole is a two-step hole. You have two different diameters, two steps. That's the terminology that's used. I can also limit my area. So I'm gonna look at all the different types of stepped holes here. But I'm also going to limit my search. I don't really want to focus on the top half of my part. So maybe for my instance, I'll just window around and roughly select that top half. Once I have those selections made, I can go ahead and choose the Find Features icon. So now NX goes through and it's found a number of different features. And we can see that in this case, we found a counterbore through hole. That's not really what I want to do. This was already handled with turning. So let's remove that. And then I have some different through holes. I have one down here in the center, same thing. We did that with the turning operations. And now here we have the 4 holes that we see around the periphery of this flange. That's good, that's what I want to focus on. I'll go ahead and say okay. So what do we do here? Under our machining feature navigator, if we expand this, we'll see that 4 holes now exist. The same actions would happen had I created a drilling operations and manually selected each hole. These features would have still gotten created here in the machining feature navigator. We just did this a bit more proactively. So now what I want to do is I want to produce these features, these countersunk holes, based on my existing feature-based machining processes. So here in the Machining Feature Navigator, I have all of my holes selected, and I can choose Create Feature Process. And we have some out-of-the-box rules that exist here. I'm just going to go ahead and turn all of them on. And I can choose things like geometry location. Where do I want this to be part of? I know for my case, I want this to belong to the G55 mill group. So I'll go ahead and make that setting. I also have the ability to use existing groups or create new groups. In this case, I'll use always create new. And now here, I'll say OK. NX is going to go ahead and look at the feature-based machining database and look at the features that it's found and find the proper tooling and operations to go ahead and produce those features. All right. So it's done thinking. We can move over to our operation navigator again, and we'll see that operations have been created for us. So let's go ahead and generate some of these operations. Here you can see that using feature-based machining, our spot drilling operations are created. These are our drilling operations. Saw that we also needed to do some boring operations. And countersink. Some of these look a little bit redundant to me. Again, these are basic out-of-the-box rules that may or may not apply to you. I don't really want to do any boring things like that, so I'm going to go ahead and delete some of these operations. But now quickly, I have my operations for spot drilling, and countersinking. Let's go ahead and take a look at the results. Here, we've generated our IPW. And we can go around and see that we're going to spot our holes as expected, followed by our drilling operation. And finally, our countersinking operation. So very quickly, with feature-based machining, we can program a good number of features. You can see this was only 4 holes on this part, but we could have done the same process with many more holes and different size and type of holes. So feature-based machining is a great way to look at improving your programming efficiencies. All right, and with that, we've kind of shown an end-to-end process of NX-CAM and how flexible it can be in a number of different environments and applications. I appreciate you spending some time with me today, and I hope you learned something. Thank you.
Okay, let me get my part here going again. All right, so I hope that was beneficial for everybody, that what you saw today. All right, you can't hear me. I'm having a technical difficulty here, so.
You sound good, Dan.
Oh, good. Okay, great. Let me get back on. Sorry, I thought I was muted. My error here. All right, doing live. I'm a little rusty, so we're using a new tool here. But John, thank you very much. That was very informative. I recognized a few names there, so I sent a few chats out. But by all means, we're here to help explain for if there's some new features there you're struggling with or would like to. You already have them, but maybe how to approach or use it. We can definitely walk through those techniques and workflows. Some of the areas we didn't cover, there's a lot, and we have some more follow-on webinars here, and maybe in the survey, you can give us some ideas too. That would be great. There's so many tools within NX that I just don't get touched. It's I compare it to something like Outlook or Word, where we maybe use 10% of it, and what's all these other tools here. So that's our job, to help explain it to you and show you what will work best for your shop. Some of the areas we definitely didn't touch was all of these communication tools about shop floor process planning, getting DNC code out to the shop, NC code, out to the shop. How do I make updates or changes? Once again, the communication has become so critical, even more complex today. So where to start? What's next? If you haven't already, visit our website. There's some great information there. If you're newer to Siemens products, or if you've never been on the sites, please join the blog site or the community site. The community site's a great site to post questions or read other people who have posted information there. It's all about learning. So definitely go to those sites. And above all, please reach out to us. There's my email. There's John's email. You can go to our website. Just use to contact our team, whatever works for you. We want to talk with you and make this work. Or if you have the tool, make it more successful for you to be more efficient. So we will have a very short survey that will be coming up here in just probably a few seconds. Right, Alex?
Yes. Yeah. Once we close out the webinar, there'll just be a quick 4-question survey, just to give us some good feedback on what we've presented today and what we can do better in the future.
Yeah, and please let us know areas you would like to see, and we will put something together for you on that. But everybody, thank you for coming, and sorry for the technical difficulties, but I hope you all or leaving with something that you didn't have before. So look forward to speaking with you all again. Goodbye.